Welcome to the 5.4 Proportion Word Problems Notes. Today we're going to talk about a specific type of word problems that involves proportions. And the first thing I need to tell you is that this only works with things that have a constant rate. So like if somebody's driving the exact same speed, or if something costs the exact same all the time, or if somebody's working at the same rate, or you're using something up at the same rate, you have to have that assumption first. Okay? Then, the most important part about solving them is that you have to have consistent units. What this means is, if you're going to put one type of unit on the top, it has to be on the top for both fractions. If you're going to put it on the bottom, it has to stay on the bottom for both fractions. Now, we're going to take a look at two examples down here. It says, circle the example that shows a valid proportion. Now, you're looking for the one that has the same unit on top for both. And because this one switches from miles to hours, that one's not it. It has to be the other one because miles is on top for both of them and hours is on the bottom for both of them. Okay? So make sure you cross out the one on the left because I don't want you to look back and think that that is correct, because it is absolutely not. That means that when you're setting up a word problem, you just have to make sure that if you put like miles on the top, it stays on the top. So for example, on this first one, we have a 100-ounce jug of laundry detergent that washes 64 loads of laundry. Now we're going to assume that that stays true no matter how big of a jug of laundry detergent you buy, because it's still the same laundry detergent, you're just buying more at once. It doesn't change how well it works. Then we want to know how many loads a 150-ounce jug can wash. So I'm going to set up a fraction from the first sentence, and that is 100 ounces over 64 loads of laundry. Perfect. And this has to equal a fraction that uses the 150. You just have to decide, where do you put the 150, on top or bottom? Well, we have to keep it ounces over loads of laundry. So, since 150 is in ounces, it goes on the top. And we don't know how many loads it can wash, so what do we put when we don't know something in math? A variable like x, or y, or z, or question mark. Use a smiley face for all I care. You just have to put something there to represent the unknown number. Then what we're going to do is we're going to use our cross products to solve this, like we did in 5.3. And I'm always going to start with the cross product that involves x. So that's this one. 100 times x is 100x. That's easy enough. Then you put an equal sign, and you go ahead and multiply the other one. 64 times 150. Then we want to get x by itself, so we have to go back to our equation solving skills. If there's a 100 in front of the x, nothing in between, they're being multiplied. So you divide by 100 to get x by itself. And the beauty about dividing 9600 by 100 is it's just going to be 96. The 100 part cancels out. But before you finish, 96 what, ladies and gentlemen? 96 loads of laundry. Don't skip out on the units, because the units are what tells us if we actually got an answer that makes sense. If 100 ounces can do 64 loads of laundry, 150 should do something more than 64, like 96. Okay, let's try another one. A store receives 52 online, that should say orders, per day. At this rate, how many orders can they expect in the month of September? Okay. So if we've got 52 online orders, and I'll fix that for your guys' copy so you won't have to do that. That means 52 orders in one day is going to equal, we don't know how many orders, but order has to stay on top, over, now we have to figure out how many days are in September. Well, lucky for you guys, I already know that September is one of the months with 30 days. Then we do our cross multiplying. 1 times x, that's 1x, equals 52 times 30. 1,560. And this time I don't have to divide by anything because there's just a 1 in front. So our answer is 1,560 what? Orders in September. Now I know that that sounds like a lot probably, but it is an entire month. And there you go. Okay, we're going to keep trying them, and I'm going to keep setting them up the exact same way, guys. The only thing that's slightly going to change about this next one is it takes 1 1/4 cups of milk to make 8 pancakes. 1 divided by 4, which is 0.25. What we're going to do is we're going to go ahead and circle this and write that 1 1/4 is just simply 1.25 cups of milk. Okay, and that makes 8 pancakes. Now when I set up my other fraction over here, I just have to make sure I keep cups on top and pancakes on the bottom. And what is the third piece of information we know? Boom. 20 pancakes. Since it's pancakes and pancakes is on bottom, 20 goes on bottom. And the X, the thing that we're missing, because it says how many cups, that means that that is what your X is. So that's why X is next to cups on the top. Now, you've got it set up, you just cross multiply. 8 times X, 8x, equals 1.25 times 20. 1.25 times 20, 25. And then you divide by 8. 3.125. So you need 3.125 cups of milk. There you go. Let's try another example. Jeff drives 112 miles in 75 minutes. At this rate, how far can Jeff drive in 2.5 hours? So we have 112 miles over 75 minutes. And we are looking for X, how far he can drive, so that's going to be miles, which has to go on top because we put miles on top on the other side. Then I have to change hours to minutes. So I'm going to go ahead and come over here to the left side, and I'm going to say that the number 2.5 is the same thing as 2.5. And I know that there's 60 minutes in an hour, so I'm going to multiply that by 60. And that's going to give me 2.5 times 60. 150. So 150 minutes. Now I'm going to cross multiply. 75 times x is going to be 75x equals 112 times 150, 16,800. Then I divide by 75 on both sides. $16,800 divided by 75 is 224. So if he goes 112 miles in 75 minutes, he can go 224 miles in 2.5 hours. Perfect. Last two. Approximately 4 out of 5 students at EHS have cell phones. If 416 students have a cell phone, how many total students attend EHS? So 4 out of the 5 have cell phones. So I'm going to put 4 have over 5 is the total number of students. And that's going to equal, we don't know how many there are total, so that's going to go on bottom. But we know that 416 have them, and that's going to go on the top. Then I cross multiply so that I can find x. So 5 times 416 is 2,080. And the other side's pretty easy. X times 4 is just 4x. Then, to get x by itself, I divide by 4 on both sides. Is 520. So x is going to equal 520. What were we looking for? How many students total attend EHS? So 520 students. Last one. Jack bought 3 binders for $13.17. And just a reminder that when we are doing problems with money, the money is going to go on the top most of the time. So $13.70 for 3 binders. I know it's probably a little backwards than what some of you may have wanted to set it up, but it's just easier if we put money on top all the time, so it's just a general rule I'm always going to follow. Then it asks, how much money will he have spent in total if he buys 5 more binders? So, side question, if he buys 5 more binders, how many binders will he have bought total? 8 binders. So instead of putting the 5 more binders that he's buying down here, I'm going to put 8 binders because it wants to find out how much he will pay for in total if he buys 5 more. And we don't know how much he's going to spend yet. Then I'm going to cross multiply. 3 times x is going to be 3x equals 1317 times 8. I don't know what 1317 times 8 is. 1317 times 8 and then to get x completely by itself, we divide by 3 on both sides. 105.36 divided by 3. $35.12 what? Dollars. And if you set it up correctly, you can always look right back up here to see, oh, we put a dollar sign next to x, so it must be in dollars.